Most of us are familiar with triple 13, right? Or triple 19, some sort of fertilizer. So in every bag, you'll see a guaranteed analysis. And so that guaranteed analysis means that if this were a 100-pound bag, there would be 13 pounds of nitrogen in it. This is a percentage. There are 13 pounds of P2O5, and there are 13 pounds of K2O in a 100-pound bag. Is that making sense? It's just a percentage. So if you would multiply 100 times 0.13, and that's how I got 13 pounds. So all we're going to be doing here is multiplying and dividing. You just have to figure out which one we're multiplying and which one we're dividing. Okay? So for our first problem, you'll always, well, not always, for the most part, you're going to set your fertilizer problems up as rate over analysis. I'm going to specifically spoon feed them to you as rate over analysis to get that into your brains. Okay? If you're not good at math, you will be by the time we're done. So, our first question, you'll get a soil test back, and it'll tell you that you need 175 pounds of nitrogen in 1 acre, and in 1 pound of 1152.0 fertilizer, there are 0.52 pounds, there are 0.11 pounds of nitrogen. Just a percentage. And if you'll start out setting your problems up this way, you won't have that big of a deal when we go to figure out whether you're putting out pounds of nutrient or pounds of fertilizer. Typically, when I say how much, that's going to be what goes on top. And so if we multiply this straight across, we have 175 times 1, which is 175 pounds of N. And if we multiply straight across here, we have 0. And when we do that math, what do we come up with? Correct. Correct.
1,590.
How much?
1,590.
Is it perfectly 1,590?
0.9.
So 1,590.9 pounds of 1152.0. Our pounds of N are going to cancel here, and we're left with, our units are 1152.0, which is the fertilizer material, over our area. So rate over analysis. I kind of teach this a couple of different ways because when I was going through this, I've been doing fertilizer calculations since like 2007. And turfgrass fertilizer calculations, which are completely, they're on a different level. And I was like, how come the point is on bottom? I understood why. I understood why the 0.11 goes down here, because they showed me and I just said, yes, sir. And that's what I did. When I got to my master's, my PhD, I was like, but how do you get it on the bottom? Where does it come from? Well, because I got the 0.11 from the fertilizer. If I were asking you for 175 pounds of P2O5, how many pounds of 1152.0 would I need? 0. What goes on the bottom?
0.52.
Huh?
0.52.
There are 0.52 pounds of P2O5. Remember, we had N, P2O5, K2O. So it's just knowing which one I'm asking you and where to get the number from. Rachel, you got this really confused look.
Oh, it's just my face.
Okay?
I got it.
I got the same one. I got the same one, right? And so what do we get here? We got someone with a calculator? I got a feeling you're going to be my mathematician.
336.5.
So this would have been 336.5 pounds of 11.52. Everyone kind of understand what I'm doing here? I'm going to need more of this fertilizer material because I don't have.
I was just gonna ask our answers. Do you want us to just round to the next step, or how do you want to do it?
Let's round it to the nearest 2 decimals. Okay, so you should typically have 2 decimals unless otherwise. I'll typically put that in the question in the like so. What I'm doing is I'm setting you all up. We're going to be doing math kind of for the first couple of weeks, just to get you comfortable with it, because you're going to have calculation 1. It's going to have some fertilizers and some other calculations. In that quiz, because you'll be able to take it multiple times, I'll tell you what you should and shouldn't be doing, like where to round up, when to round, okay? But typically, let's just go for 2 decimals. And listen, if your answer is not the exact same as mine, as long as it's pretty close, I understand you just did the calculation straight through. So it's just rounding error. So don't freak out if your answer is not the same as the other person or mine, just as long as it's close. Everyone kind of understanding what's going on here? All right. Y'all go ahead and try number 2. And number 3. You just set it up the same way. All right, for number 2, I got 278.95 pounds of triple 19. For number 4, I got 393.94 pounds of, oh, I'm sorry. For number 3, I got 358.33 pounds of 0060. Got a lot of head nodding, right? It's kind of some simple math. We're in soils. We don't do we don't do physics, calculus, maybe a little bit of geometry, maybe. We tend to keep it, I'm going to multiply and divide, and that's about the most, maybe add and subtract. It's about the most that we do. All right, what about number 4?
689.4.
689.4. Y'all go ahead, that's fine? I just worked one ahead. Go ahead and try number 4. Start out the same way. I guess you can go ahead and do number 5 as well.
On that 395 pounds, if you just apply 20% of that is measuring 20% of. What do you do on your own?
Sorry.
All right, so for number 4, in 1 acre, we got 393.94 pounds, but we had 1.75 acres. So that total comes out to be 689.4 pounds of 330012F. You want me to? Okay. Cheat. Keep some of this stuff. All right, let's do this. So our soil test recommended that we needed 130 pounds of nitrogen per acre. And using in 1 pound of 330012S, there are 0.33 pounds of nitrogen. And that comes out to be, someone got a calculator? Did y'all come up with 393.94 at that point? Okay, so this is, and so I guess kind of the reason why I set this up is because some of us might get a little turning in our stomach. And remember chemistry class, they call this stoichiometry. Y'all remember that? Saw some eyes roll. You can cancel those units. And so we know that we need 393.94 pounds of 330012S per 1 acre. Now, we'll come down here. I'm just going to do fertilizer in 1 acre. And we know that we have 1.75 acres per field. When we do that math, acres cancel, and we have 689.4 pounds of fertilizer, which is this per field. If y'all are math whizzes and you can just do that math straight through, I'm okay with that. I like to see your units. They're important because if for some reason you get them flip-flopped, you know, they say show your credit, you know, show your work so I can give you some credit. If you just go 130 divided by 0.43 times 1.75 and you get the wrong answer, I can't give you any credit on that because I don't know where you got it mixed up at. But if you show me where you did your work, I can go, you know what? They just forgot here, I might be able to give you a half of a point. Oh, they used K2O instead of the P205. Like I can see where you might have made the mistake and I can go, hey, this is where you should have done this here, you should have done that there, and you improve from that. You don't put any units, I have no clue what you did. I probably do, but to get us in the habit. Did you get it back there? That makes more sense now? Everyone else kind of seeing how we did that? Okay. And so then for number 5, I got for 1 acre worth of for 1 acre's worth, I got 206.52 pounds per acre, and I have less than an acre. I have 0.69 acres, so I just multiplied that number times 0.69. If you can do that all the way through, and you can make sure you show me where you did the math, I'll be okay with that. So then I just multiplied 206.52 times 0.69 and came up with 142.5 pounds per acre.
Yeah, ours is 0.79.
It's okay.
Okay.
Yeah, I'm not, but you had 142, right?
No, it's because we had a different amount of acres.
Did I do that wrong again? It's twice I did that. Okay, so 0.79, what'd you come up with?
163.15.
So, okay, I did this in my fertility class too. For some reason, 69 and 62, I wasn't looking at that. Whichever. Again, I'm human. I mean, if you show me that math, if you show me the math, I can see where you just put the wrong number in. Might have just read it wrong. I can give you some credit for that. But if you don't put the numbers there, and you got the wrong answer, and I can't decipher where you may or may not have took a wrong turn in Albuquerque, then I can give you some credit for that. All right. So now it looked like number 6 was something that was giving everyone a little head scratching, which is just going to be the opposite of what we just did. We applied 395 pounds of 20, 15, 25 for 1 acre. And remember, this is N, P2O5, K2O. So this is 20, 15, 25. We've already applied the material. 20% of that 395 pounds is nitrogen. Rachel just looks super confused. I'm just like, I gotta realize that's her face, and then I got the light glaring too. How about it, Shanti?
I just can't see
Oh, you can't see it? Do I need to write it bigger?
if you want to.
Sure. Better? Okay. So I'm also recording down here too. So if you can't see it, they can't see it. And so what do we get? When most,
79.
how many?
79.
So 79 pounds of nitrogen was applied. How about for P2O5?
59.25.
How did you get that?
I multiplied the 0.15 pounds of P2O5 over 1 pound of 2015-25.
So what she did was this. What was your answer? 59 point?
59.25.
Clicking? Kind of? So then how many pounds of K2O do we apply? And we put 98,
Probably can't see that, 98.25.
K2O. That's very similar. Ma'am?
7.5.
Oh. All right, you'll go ahead and do number 6. I'm gonna tell you this. Number 6 is where, like, this is the reason why this is important. You're gonna do number 6 the exact same way.
You're not adding all of them?
No, because these are like each of the nutrients. And so, what this 333 represents is like a poultry litter application. Anybody work with poultry litter? Smart. But you may hear some people talk about wanting to apply some organic material, such as poultry litter. And they're going to go apply 1 ton of poultry litter because they got chickens and they got to get rid of this manure source. So pre-vet kind of goes into this too, animal science. We got byproducts that we're trying to utilize as well. And I got this all recorded too, so I'll post this online. It sees the board a lot better than y'all do. Okay, but the problems are going to get set up the same way. You just have to know when to put it on top and when to put it on bottom. And don't worry, I'm going to feed you enough of those that by the end of the semester, you know which one's which.
Oh, we have 360.
Use 2,000.
No. Thank you. I changed this up this morning.
Alright, so we applied 90 pounds of nitrogen. We applied 180 pounds of P2O5. And we applied 90 pounds of K2O. The nitrogen and the K2O I'm okay with. I'm alright, those make sense, right? That's probably what you would want to do. You got some manure, you're going to catch up on some nitrogen, save you a little bit of time at the a little bit of money at the co-op. What I don't like is that you just applied 120 pounds of P2O5. That's not good. There's too much of that. That's what is causing the eutrophication in our waterways. That's the reason why people are against poultry litter. Because that phosphorus is what's causing the problems in our waterways. So if we want to minimize, you shouldn't be applying that much P2O5. So how this applied really was one of my professors at Mississippi State. He comes in, he's like, yeah, man, I went out there and I applied 400 pounds of triple 13 and another 100 and something pounds of some 1846 or whatever. And I was like, wait a minute, you did what? You just realized that you put like 100 pounds of P2O5 out for no reason? But he was trying to put nitrogen on his corn, so he ended up over applying that nutrient. That's where that would apply. Okay? I guess we'll do 8 through 11 next week. Alright? Think y'all did great. Everyone feel confident, comfortable. Anyone having some problems? If you have problems, ask me. I'm okay helping out. This gets you to your... Thank you. I know someone else. Who else had to go to the... Who else has the capstone? So I got 3 of y'all. Okay, that's cool. This will get you there on time. Alright?